Let's have a look at the math behind the periodic order quantity, which is more an element of time, closely tied to the concept of lead time offsetting. So the periodic order quantity, which is to say, when do we order in time, is the EOQ versus the average weekly demand. Now, this is a different example from the one we saw previously where the EOQs were at 200. This is a completely different example. We're now using an EOQ of 2,800. We want to make that distinction. But also point out that it's EOQ divided by average weekly demand. We talked about this a little bit in the use of averages in supply chain. Averages are nice, but they don't tell us much about variation, which in this case would be variation in demand week to week. The assumption across a global supply chain for hundreds, if not thousands of products is that the average weekly demand really captures the idea of variation. It is a dangerous assumption to make. What does that all mean? Well, an average is one thing, but the variation from the average is what is really important, which is to say demand in 1 week could indeed be 1,000 units, but the next week it could be 2,000. The week after that it could be 500. So POQ has some inherent concerns around it. The biggest one being, the biggest two being, all of the concerns we pointed out around EOQ, and then this whole idea of averages. Averages in supply chain are fairly dangerous because they don't address the issue of variation, whereas the standard deviation does. That's a substantial conversation well beyond the scope of this introductory supply chain class, but be advised that really being able to focus on supply chain improvements calls for, without question, the use of the standard deviation to identify variations in supply chain. Enough on that. But what we're saying here is that if our EOQ is 2,800, we did a whole other calculation using our formula. Our average weekly demand is 1,000 units. Well, the periodic order quantity, the time in which we order, in this case is 2.8 weeks. This is just rounded up to 3. So we're going to be ordering on a 3-week basis. The need to tie this into lead time offsetting becomes hugely important, because lead times, you'll see here that there's no real consideration of lead time in this conversation. And once again, in a global context, that's a dangerous approach to take. So the tie-in between periodic order quantity and lead time offsetting, very, very important. But just to reiterate, POQ, it's about time. EOQ is about quantities, as we see here. Now we're going to move on to the order point system. So it's not necessarily quantities or time periods within which we're going to be ordering. It's bullet point 1. When the quantity of an item falls to a predetermined level, what's called the order point, a replenishment order must be placed. Now, sometimes the quantity to be ordered is often based on EOQ concepts. We need to make that determination. So bullet point number 3 really is the essence of supply chain management on a clear tactical level, because the key factor about the order point methodology is that it considers product demand during lead time. How much product are we going to need during the lead time within which we are replenishing that same product? Lead time stability becomes so important in an order point system. And as we've said many times, in a global context, stabilizing lead time can be a difficult task to accomplish. But the fact remains, to reiterate, bullet point number 3, the OP methodology, the order point system, is that it considers product demand during lead time. How much do we allow a product to deplete down in terms of its inventory before we place another order? You can't do that unless we know the demand during lead time, as well as, last bullet point here, safety stock, that additional inventory that we carry in addition to regular inventory that accounts for unexpected variation in a supply chain. What's an example of unexpected variation? Lead time disruption. customs delays, containers don't make a sailing on a vessel, air freight gets knocked off of an aircraft because of space constraints, things like that. Demand during lead time and safety stock, two very important elements of the order point system. So admittedly, this is a pretty basic calculation, two variables and a little addition, but the easier it seems things are to talk about in supply chain management, the harder they are to execute upon. So we want to go visual, as we've said a couple of times, and bring this to the forefront. We have an actual example, a couple of examples in just one moment. But the order point is that demand during lead time plus safety stock. Allowing a merchandise inventory of a particular SKU to deplete down to a certain level, 100 units, let's say, before we place a replenishment order. That's the order point. But in order to be able to do that, we want to make sure that while the goods are being replenished, the lead time it takes, 2 weeks to get a replenishment order, let's say, that we don't run out of merchandise during that lead time replenishment period. That's really what it comes down to. In order to do that, to determine the order point, we have to know what we expect to use during that lead time period. It takes us 2 weeks to get more merchandise. What's the demand going to be during that 2-week lead time plus safety stock? So using some previous examples, let's say it's a 2-week lead time and 100 units. Demand during lead time is going to be 200, and if we keep an extra 50 for safety stock, equals 250. So for this particular SKU, when the inventory gets down to 250, bang, we replace with an order. And if we're using an EOQ calculation, that's the amount that we're going to order. This is really the essence of the whole order point system. So demand during lead time plus safety stock defined as additional inventory that we carry to safeguard against supply chain variation. And we've given a bunch of examples on that. Let's plug in some numbers and see how it looks. So our calculation remains the same. Our lead time here is a little different than that ad hoc example I just gave. We're talking 3 weeks here, but the demand is 200 units per week. So if lead time is 3 weeks, demand is 200, that's this calculation right here, 600. Safety stock, we made some determinations with some other math that our safety stock is going to be an additional 300 units. So our order point here, the point in inventory depletion of this specific SKU that we're going to let that inventory go down to before we reorder is 900. Why is it 900? Because it's going to cover the demand during the lead time while we're waiting to get more stuff plus safety stock. So this particular item, we can't reorder. This is built into the algorithms of our software that we use until we get down to 900 units. We reorder. Let's hope that lead time is stable because we're going to use 600 of them, of the units, during the lead time, plus we have to keep an extra 300 around anyway. That's how this works. But imagine having to go through this entire exercise on a global scale for thousands and thousands and thousands of products. Real easy to talk about, not so easy to do.